Ladies and gentlemen, my name is Dušan Vukotić. I came from EPS, Energy Power Serbia, operator ODS, d.o.o, Distribution System Operator, Distribucija. This is one common unique d.o.o that operate on the network in Serbia. As you know, in Serbia we have transmission system operator, also it's unique and common on the whole territory of the Serbia, country Serbia, and we also have one d.o.o. Regarding the electric network, it's very simple. We have one t.o.o and one d.o.o, and we have one relationship one-on-one in our mechanism to exchange or supply energy regarding the distribution network system. I will add some, maybe you know, last year I have some similar presentation about integration of distribution generation or distribution energy resources into mid-voltage electric power distribution network on all territory of Serbia. This is one of the reasons why we, before 2 years ago, we promote new grid codes also for the transmission system and also for distribution system. And in this moment, we a little bit postponed the integration of the distribution generation on 35 kV level, because we not expect a lot of integration on this level, but unfortunately it's happened in the meantime, and we have a lot of new DGs on this level, and we must have some response on this initiative what we have from the private investors. Just to like what participants before in previous two presentations mentioned, we also have smart grids, we have smart buildings, we have smart cities, but regarding the electric point of view, we have smart grids. Now we divide this smart grid into smart grids and microgrids. Microgrids is dedicated on the low voltage network, like what Autor presented the previous presentation regarding the smart buildings. But for our point of view, it's very important that we integrated all DGs, all the type of this new photo PV sources on electrical cars, new storage, wind farm, generation. It's everything now on the network, integrated in one common system. But also we must exchange also a lot of information between these resources, but we must very efficiently transport this energy to the end users. This is a completely new philosophy regarding in our network, because traditionally in previous time we had, before 10 years ago, only one directional low flow. Now it's completely different story. We have bidirectional low flow with a lot of flows in sometimes in one not expected direction, but we reduce actually this traditional generation what we earn from the thermal plant or the hydro plant, what we have with huge installed capacity. Actually, this is an initial stage of future full decentralization of the electric power system, but in this moment we try to on a very efficient way to integrate all these resources on our network, and based on this we make some criteria and rules how these resources could be integrated on our network. These criteria and constraints, it's based on European Community regulation. It's quite similar like in other countries in Europe. And in this matter, we following this directive what we receive from the European Community. Next slide. In present time, t.o.o and d.o.o have quite different roles in the system. Before, this is we receive low flow directly from the t.o.o in one direction, and in the previous time we also have some old-fashioned DGs but this correspondence, it's in DSO, we exchange energy, we receive some surplus of generation what DGs produce, and in previous time it's not have this quite this market framework what we have in this moment. It's regarding the technical point of view, it's not a big deal to integrate it or exchange, integrate new resources, exchange energy, exchange information. But what is for us very big constraint, it's market influence on our framework what we have in the system, because there is a lot of new mechanism regarding the market what present now on the field, and also there is a new actors like integrators or some and others who try to sell, to integrate it and sell energy. Also traders is present on the market, and all these new actors give new dimension of the problem. Also, there is quite new services what these actors provide, and these services, it's in this moment for us a little bit unknown, because we know what we expect for these services, but it's very hard to provide like balancing, like how TSO balance some generation or some resources deeply in our network, because DSO not have any responsibility to balancing in this moment. Only balance responsibility is based on DSO roles in the system. In the future, we expect that it's changing. In this moment, we have some clear signal to be, then our regulatory agency will little bit change this mechanism, but actually we, in this moment, we're not like DSO ready to be balance sector on the network. Our connection between TSO and DSO is connected over than some main substation. Basically, this is a 110 kV voltage level to transfer on the 35, 20, 10 kV level. And there is a different way how some new DGs could integrate it on the network, even then integrated on the TSO level or the DSO level. The best point to integrate it, because some investors want to reduce their cost of integration, is then these DGs directly connected in the substation, because the substation already have some infrastructure regarding, then we already have some part of the electric facility there. Maybe we have some spare feeder bay. Even then we have also telecommunication infrastructure, and also we have another condition which would be able to very easy to integrate these DGs in the network. But unfortunately, another problem, then we also have some technical regulation, because we designed this substation based on some little bit old-fashioned tradition design, and also we not in this substation integrated new IDs based on microprocessor technology. This is old-fashioned electromechanical protection device, and this is a reason why in the last time we spent a lot of money, a lot of budget to reinforce this main substation. Regarding then we exchange equipment with new one, also basically with new type of the circuit breakers and disconnectors and all this primary equipment, also with two integrated microprocessor protection devices, and also new generation of the remote terminal units. One of the criteria what NSOE organization, this is an organization who cover all these TSO activities, and all TSO in Europe participate in NSOE organization. They try to, based on some criteria, they divide in several ABCD group, and based on the installed power, then they make clear one edge what is installed based on installed power, or could be some criteria to integrate it even in TSO or then d.o.o. In practice, it's not clear because they put for the one class a very high level of this installed power. In the practice, in the first moment it was 50 megawatts electrical power, but in the practice this boundary is reduced on the 10 megawatts, but in the last time we reduced on the 5 megawatts. This is now a big discussion about what is a really boundary, what's the limit of this installed power when we choose on which level we integrated these DGs. What we have now in the network, based on previous concept, then we have the distribution system electric network. They have two types. One is the load, one is generation, one is the storage. In the old-fashioned traditional network, regarding the very high price of the storage, we have just load or generation. But in last time, and based on this concept, in the previous time, all DGs try to maximize own profits on way, then they directly connect on d.o.o. electric network and transfer all production to the network, and for their own needs they take a load for auxiliary consumption based on multiple time cheaper price. This is regarding this market condition, it's very useful, but regarding for us, for this d.o.o., it's not so much optimal, because in one point we must obtain full portion of the generation, but also in this point we also must deliver some loads for own needs for this production. It's a little bit change on the market now. They now implemented prosumer. This is not simple consumer. This is a producer and consumer. It's very good words to describe. In our Serbian language we not have this, and it's very complex, but prosumer is it's now paradigm, and it's mean then it's one point. There is some customer who have own production, and with production he satisfy own needs from the electric power, and surplus of this production deliver it to the d.o.o. electric network. It's mean if you have some diagrams like illustration, then if you have some load, this is a blue shape, then it's also you have some PV on the roof. It's mean then during the day you will cover the portion of the electric power needs, what you produce from the PV sources, but you have some surplus who will transfer to the network. There is a lot of variation. If you install PVs, then you install some micro motors, gas motors. There is a lot of technology who could produce now this energy. The diagram is quite different, but it's just important then not focus on just on feeding tariff like the previous. Then producer want to maximize on product to deliver a full portion of the production. In this case, the portion of generation is spent on the own needs. Also, in the last period, the price of the storage is a little bit reduced. It's still high, but there is a lot of but a lot of there is an installation who install storage in these properties, these houses, facilities, and this surplus put in the storage, and storage cover loads. Also, when we have some outage on generation or storage system, it's able to receive load from the d.o.o., but also storage could, in some period, based on some special tariff, could delivery in the d.o.o. electric network. This is something, what is now it's framework. This is also based on this I mentioned regarding this technical requirement, it's not so much big deal to integrate it and exchange and make these connection points. But regarding the market, it's very complex, and it's always talking about what is the price when we receive energy, what is the price when you produce, when you inject in the network, and we try to make these prices unified. Producer want to have some differences, and this is something what it's on the market, and it's true that the market can solve all this, but market could reduce, but we always have this little bit difference, this gap between these tariffs. About energy flow, this is energy parameters for the last year in Serbia. We have actually 5 parts of distribution area in Serbia. It's not unified. In Belgrade, it's small territory, but it's very high consumption. This is more than even than Vojvodina, who is the province on the north. But also we have a problem with migration, because also we have this strong influence on immigration, and from south and some faraway location over the border of Serbia, then they migrate directly to the main center, Belgrade, Novi Sad, Niš, and Kragujevac, and this is the reason why in Belgrade we have very high increase every year, because in Belgrade every year we increase maybe about 30,000 new citizens in Belgrade regarding the new distribution code what every customer have. This is every between 10 or between 10 and 12,000 new customers per year what we integrated in our network in Belgrade. Even in Novi Sad a little bit, it's maybe twice time less, but in Belgrade this migration is very, in this moment it's very intensive, and we have this very strong need to satisfy this need regarding the electric power. I agree, it's what in discussion before that you mentioned, it's this problem, it's open issue what we have when we're talking about smart cities, but problem with energy, it's also big one. Everybody wants to have migration, need new flats, new buildings, commercial need very high buildings, all this stuff. Even then we reduce regarding the energy efficiency, then we also need very high portion of the energy what this building need and what they want to receive for our network. Regarding, based on this our response based on this new influence is not so much rapidly, and we need to take a time to build new substation who will cover regarding them on the highest voltage level. This is something parameters regarding DGs what we install in Serbia. You can see that it's the biggest part of the hydro potential, and because we have very high hydro potential, this is the reason why we have micro hydro plants. Also we have biogas, wind, solar, cogeneration in the last. I will little bit speed up, and this is installed capacity in 2016, 2017. You can see that we enlarged the DGs on the 35 kV. This is installed capacity per voltage level what we have in Serbia. You can see that we not have so much progressive way on the low voltage level, or even then we not installed yet this microgrid, but we try to install on the highest, on 35 and 10 and 20 kV. On the left side, this is a source who is owner of EPS. This is very old, basically hydro plants, and in the last 15 years we not build up new capacity, but in the future we have a plan to the next, and forward and we install new capacity on basically 35 kV level. One of the problems what we have in Serbia, what we indicated that we have injection in TSO. It's because we have lack of the loads in some part of the network. We have backfeed to the transmission system operator network, and basically its effect starts in 2017 and continue on this year, and you can see that it's twice time the biggest than even than last year, because it's reason why install new wind farm capacity with very big installed power, and this consumption this area when we integrated this wind farm, it's not this load, it's not so big because migration of the population from this part it's to the big cities, and we have a reduction of the loads. This is the reason why we install. When we make analysis, it was completely different story, but now in the practice, after 3 or 4 years when we install this capacity, we have a problem with this. This is some, this is, sorry. This is some, I don't know what's happening with the slide. This is a monthly, in January, May, and October, and you can see I can see, you cannot see, but in the May and October, it's a portion what inject in the transmission system. It's same, but it's twice time less in January, because in this period is very high consumption of the electricity from our customers, and this is the reason we do not have this surplus. When we load during the summer and October going down, because this is some very sensitive weather months, it means that in this period we have very big surplus, because even in this period it's been very strong. And regarding location TGs, it's very interesting what I mentioned. Then we have hydro potential on the south and the west of and it's outside of the big cities. Also, it's same situation with wind. This is on the east near the Romanian borders. And regarding the solar, this is in the right corner down. This is on the south. You can see that all this potential what we have from the hydro, wind, and solar, it's far away from the big cities, and this new big appetite what new big cities have regarding the electricity, it's not simple. It's not simple to deliver, to transfer this energy what produced from DGs to the big cities, because we have a lack of the load in these parts, and we have big losses regarding this transfer, this energy to the final consumption. Concept on integration DGs on 35 kV, this is something new. Very little last year talking about this. This is something that will be presented new with codes, and based on this common scheme, all this variation of the integration of DGs on 35 kV voltage level will be implemented. One of the big projects that we have in Belgrade, this is a cogeneration plant. In Poždovac, it's a thermal heating plant, cover one part of the big part of the Belgrade with thermal heating energy. And the city has a plan to install there one cogeneration plant with 10 megawatts electrical power. And we make big analysis, what is useful then integrated on 10 kV or even then 35 kV, and finally we decide, then we make agreement to our thermal heating company in Belgrade, then they connected on 35 kV based on this concept, and the interconnection point is between two main substations. And it's very useful because we can share this direction of the energy flow, and we will basically cover with this energy one very high loaded substation in the urban part of the Belgrade. In Belgrade, we don't have a problem with load. All our transformers is not overloaded, but it's optimal loaded, and maybe it's 80–90% of the loads. And with this injection from DGs, we reduce a little bit this load on the basically on optimal level and reduce the losses. What is the primary goal from this integration? And okay, this is something about architecture. This is very modern, based on the latest architecture of the connection. We also provide cybersecurity, because in this, when we integrated this very complex system, we need to have coupling and exchange information between these two systems, and based on some solution what we provide there, based on differential line protection, we provide cybersecurity. In matter of the cybersecurity, we also have very good results. And finally, conclusion. Increasing presence of the prosumer dramatically changed the structure of customers with completely new influence of the electric distribution network. We expect that the prosumers in the future completely change this tariff, then we reduced feed-in tariff, and we, based on this surplus for prosumers network-wide, then provide a very good condition, very good prices for both sides, from customers and for us. But we expect a very dramatic increase of these prosumers on the network. Even in the moment, like in Bordovac, they also have some very high loads from the network. This is more than 3 megawatts. And when they make this plan, we try to promote it. They also thinking that they could be prosumers, but there was very strictly, because they want to fully generate it in the network and receive load from home. And this is a surplus of the 7 megawatts. But in the future, when they reduce this tariff, maybe they will change characteristic of the own consumption to be prosumer. I mentioned then we now talking about edge of the 5 megawatts in installation capacity when we analyze, and it's most important that we now, when we make this and make analysis and make a study of the interconnection, then we have 6 criteria to integrate in the network, but no on this criteria not take in consideration loads. It's very important that we take loads in consideration, and based this new approach, then we reduce this injection in the network, on transmission network, because on this way we already take this electricity from this producer. We market operator paid this, but TSO have more benefit because reduce own losses. And I mentioned it's very important that we group this. I not clearly mentioned that, because all this injection on these points, what we have in network, in this point we have 7 points when we inject in transmission network, all this group in one virtual power plant, but unfortunately in this moment we don't have price for delivery from virtual power plant, and this is something what we must in the future with our agency work on methodology for determining for price of grid acts. This is a little bit very complex story, but I try to, on a simple way, to present to you it's regarding the electric network, what is the also one precondition to establish a smart buildings, smart cities, smart grids. Actually, thank you very much.
Thank you very much, Mr.